This is Lesson 1, Addition and Subtraction of Fractions and Lines and Segments in Algebra 1. So, let's go ahead and review some addition and subtraction of fractions that you've had since you were a little kid. And let's see what we can do here. Alright, so a couple of the things that are important to know are some terms. One term is called a proper fraction. So P-R-O-P-E-R, and that is when the numerator, the top number, is smaller than the denominator. When we have what is called an improper fraction, that's when the numerator is bigger than the denominator, like 6 over 5. And then what we have is called a mixed number. And that is when we have like a whole number, like the big number 3, and then we have a fraction attached to it, like 3.5. Okay, and just to give you an idea of what this means, is it just means we have 3 of something plus another 1/2 of something. So we have 3.5. Alright, so those are the 3 terms that you're going to need. Now we need to figure out what we're going to do with those when we add and subtract fractions that are one or all 3 of those. So we'll start out with some proper fractions, like 1/3 plus 2/3. Alright, they're both proper fractions, and one of the things that you see is that the bottom numbers are the same. In order to add and subtract fractions, that has to be true. The top number or the bottom numbers have to be the same. And what we do is we just add the top numbers, the numerators, and whatever number was on the bottom, we drag along with it and put it in the answer. Now we have 3 over 3, and if you remember, any number over itself is always 1. No matter what that number is, any number over itself is 1. So what happens when we have something like 1/3 plus 2/5 when the bottom numbers are not the same? Well, when the bottom numbers are not the same, we have to make them the same by finding what is called the least common denominator, the smallest number that both 3 and 5 will go into, and that will end up being the bottom number or the denominator. So we look and see what numbers 3 goes into. Well, 3 goes into 3, 6, 9, 12, 15. I mean, you can just make this list go forever and ever. And then we can take the 5 and do the same thing until we get a number that is common to both the 3 and the 5. So right here we get a 15, and right here we get a 15. Now we'll learn some different ways of finding the common denominator later, but this one seems to be real simple when the numbers in the denominator are pretty small. So now I know that both of them have a 15 in common. Both of them divide evenly into a 15. So that being the case, we're going to change the 3 to a 15. Well, what did we do? What did we multiply that 3 to get it to be a 15? We multiplied it by 5. Well, if we multiply the bottom number by 5, we have to multiply the top number by 5. So 5 times 1 is 5. And we also are going to change the 5 to a 15. Well, what did we multiply the 5 by? A 3 here. So we have to multiply the top by a 3 as well. So 5 times 3 is 15. 2 times 3 is 6. Now what do we have? We have a 15 on both the denominators, so that means we can now add. And when you add fractions, remember, you're only adding the top number. The bottom number is what was common, and we get 11 over 15 for our answer. So that is a quick review of finding common denominators. The same is true when you subtract. You do the exact same thing, only instead of adding your numerators, you're subtracting your numerators. Now sometimes when you're adding numbers together, you get mixed numbers. And remember, I said a mixed number was a whole number and a fraction stuck together or added together. So what we're going to do is we're going to add those, and what I like to do is put them in vertical form here. So I like to rewrite them this way, and you'll see why in a little bit. But our denominators are the same, so my answer is going to have that denominator. My numerators, I just add those up. And 13 plus 4, I add those up. And I get 17 and 5/5. Well, in this particular one, 5 over 5, I have one number over another, and both of those numbers are the same. So when you have the numerator and denominator that are the same, you can replace that with a 1. So this actually is 17 plus 1, or 18. So when you add these mixed numbers together, you end up getting 18. Okay, so let's look at this one, 13 and 3/5 plus 2 and 1/8. Now again, I'm going to write it in a vertical way. And the key thing is I cannot add my fractions together because I don't have common denominators. So I have to make common denominators before I can add these together. So you've done the addition of fractions for lots and lots of years of math, but let's just go over it real quick. The way I have students find common denominators is I take the 5, the bottom number, and I factor it down in what are called its prime factors. The smallest numbers that multiplied together will give you 5. Well, 5 is a prime number, so you can't break it down. It's already in a prime factor. 8, on the other hand, is an even number, so it can be broken down. It can be broken down to, if you remember doing the factor tree, where you find two numbers multiplied together to give you 8, and you circle the prime number, and then you make another factor tree piece, and you find out what numbers multiplied together to give you that. In this case, it's 2. So 8 reduces down to 2 times 2 times 2. And then I can erase that. And what I do is I look at my row of factors for 5, and I see 1 occurs. And I look down here and I don't have any 5s that occur. Well, then that case, then this is the one I want. I want the row that has the most 5s in it, which is that one. Now I look at this row here, and I've got 2s in it. I've got 3 2s. Well, how many 2s do I have up in this row? I don't have any. So that means I want all 3 of these. Since none occur up here, I want all of these. Alright, so my least common denominator then is if I were to multiply all these together. So 2 times 2 times 2 is 8, times 5 is 40. So that ends up being my least common denominator here. So I'm going to put a 40 here and a 40 here, because I'm going to replace this and this with some fraction over here so that they have common denominators. Alright, so what did I do to go from 5 to 40? I multiplied that times 8. So that means I have to multiply this times 8. Multiplied what to go from 8 to 40? I multiplied 8 times 5 to get 40, so I have to multiply 1 times 5. So this stuff now can go away. I leave my whole numbers 13 and 2 there, but the fraction that I replaced my other one with, the one that was over here, is now, I can now add those because I have common denominators. So 24 plus 5 is 29, and that's going to be over 40. And then I add my 13 and 2 and get 15. And that ends up being my answer then, because this cannot reduce.